Hey, Dr. B here, and for our Science in the News project, let's take a look at the Ingenuity helicopter. Imagine a rocket taking off, which it's going to tomorrow, and on board we have a vehicle known as the Perseverance, and stuck to the bottom of it we have what they call a helicopter, and this is known as the Ingenuity helicopter. Let's learn a little bit about it and then answer some questions. Okay, here's a 1-minute video by NASA, so I'm going to play this in its entirety. Okay, so that's the Mars helicopter. That's the 1-minute video. Here's another video that you can watch that's about 5 minutes long. I won't play that, but that covers a lot more information. It's made by CNET, and I think it's very user-friendly. It's a fun video to watch. But if you really want to learn a lot of information fairly efficiently, I'm going to click here. This is the NASA briefing of the Ingenuity helicopter. This is pretty professionally done. This covers a lot of useful information here, and it's pretty professionally created. So you can take a look at the summary of things that they cover here. And I'd recommend you take a look at this video when this website when you get a chance. And there you go. So let's go now to the questions which we'd like you to answer. Here they are. Okay, 1, when does it launch? 2, when does it arrive? 3, well, how far away is Mars? And given that information, how far away it is and how long it takes, just do the math and show what its velocity is on average as it goes from Earth to Mars. If you want to answer it well, be aware that because the planets are revolving around the sun, and so are we, you're dealing with two moving objects, and so you do not travel in a straight line. So maybe do a little research to get a realistic number of its velocity given its actual traveling distance. It's hard to fly on Mars, or we think it's hard to fly on Mars. Humans have never flown on another planet, period. So that's kind of exciting. So why is it hard to fly on Mars? Maybe you'll find some data that shows that, at least in certain respects, it's not too hard to fly on Mars. The Ingenuity helicopter will be taking daily flights. How long? Now, a couple math questions, couldn't resist. For this one, if you take a look at this wired source, I think you'll get a lot of assistance, but you might not need it. The question is, how much energy can that battery soak up each day on Mars? I should say each sol. A Martian day is not that different from an Earth day. The sun, let's just make the following assumptions. The sun will provide 300 watts per square meter per each day. And that's an average when you consider that it's not right on top of you all the time, right? Sometimes it's not even there. And we'll assume that that solar panel has an area of about 150 square centimeters. Be careful because the area was given in square meters. No, the wattage was given in square meters. The area was given in square centimeters. Let's assume 25% efficiency. That's realistic for solar panels. And for each day, once you calculate your, once you have your watts, know that each watt is equal to 86,400 joules. Okay, and once you got that, you should have some energy data in joules. But joules are a funny unit. You might not be that familiar with them. So why don't we compare it to an iPhone? Now, an iPhone 11 is a 3.8 volt system. That's the battery on board. And it has, let's assume, 4,000 milliampere hour battery. Here's a conversion for you. So go ahead and figure out joules there. Compare these joules to those joules. And for fun, well, what fascinates you the most about the Ingenuity helicopter? Please answer it with at least one paragraph, but there is no maximum to your answer. Okay, that's the Ingenuity helicopter science project.